although tsunami was not originally one of the hazards that fell under our mandate, because of its importance and its potential impact and the fact that it is generally a secondary effect from the occurrence of a large magnitude earthquake, we consider it of sufficient importance to become involved in this program. So we recognize that to be able to have tsunami warning, you need seismic instruments, and so there was a need for us to expand our monitoring network. And we also recognized that it was not just our area in the Eastern Caribbean, but the Caribbean. So we partnered with the agencies that are responsible for this, the IOC and others. So we had a regional seismic network operators workshop in 2006 and then another one in 2008 where network operators met and discussed their challenges with instrumentation and what they had, and looking at what was there, what gaps needed to be filled, and then we went out looking for ways to fill those gaps to strengthen the capacity to do tsunami warnings. And so you would see that we have come a long way since that. Our network has increased now. We have over 60 stations in our network, and that allows primarily for our earthquake location and research, but it also allows us to share our data with the Tsunami Warning Center, which I learned today is now officially the Pacific Tsunami Warning Center. We have incorporated into our activities an education and outreach section, and we would go out and support the disaster coordinators in the islands of the English-speaking Caribbean that fall under our area of responsibility, and provide that scientific advice and expertise as they reach out to their communities to promote this awareness of the various geological hazards to which the Eastern Caribbean is vulnerable. So there is an Earth Science Week that we use every year, and we would be in one of the territories. And this last week that we are in now, we have a team in St. Lucia marking this Science Week with such a program. So I was there earlier this week and involved in the earthquake section of the presentations to allow our nationals to recognize the earthquake threat. Because of the slow rate at which the Caribbean plate moves, earthquakes, big earthquakes, occur over a very long period of time. So you would find that our largest earthquakes, magnitude 7 to 7.9, every 20 to 30 years we would get a big one like that. And every 100 or so years, one about magnitude 8. So that is long enough for people to be saying things like, but earthquakes don't happen in the Caribbean. Our plates move at just 2 centimeters per year, which is about as fast as your fingernails grow. So we have been seeing the magnitude 7s every 20 to 30 years or so. The last one was in 2007 and occurred north of Martinique. The one before that was in 1974 and occurred between Antigua and Barbuda. And then the one before that was in 1953 northwest of St. Lucia. So that pattern has been holding. So we haven't seen our larger earthquake in the 8 range since 1843. And so that is well over 100 years, and therefore we would expect that such an earthquake will occur. And you will expect, given the length of time since we saw the last one, that it will occur more likely in the short term rather than in the longer term. as far as what we would describe as background activity is concerned. And what generates the background activity, the science suggests that the faults that generate earthquakes are distributed in a hierarchical system. And that means if you think of a pyramid, you have a large number of small faults at the base of the pyramid. And as the faults get larger, they become fewer, and you go up to the peak of the pyramid. So our background earthquakes, the earthquakes that we see in our records every day, they would be occurring on the faults at the base of the pyramid. And those that occur every week, a little higher up the pyramid, every month, every 2 months, every 3 months, every 10 years, every 30 years, every 100 years. Sometimes some of the research that we are doing at the Seismic Research Center suggests to us that you can analyze how these earthquakes are occurring, these smaller earthquakes are occurring, and get a sense of when a bigger earthquake might occur. Some research would describe it as accelerating seismicity. You see an increase in certain magnitudes of certain events. And in some areas in the Eastern Caribbean, we are seeing elevation in some of our activity. And in others, we are seeing it quiet, which is another sign that something might be preparing. So at this time in the history of earthquakes in the Eastern Caribbean, given everything that I have said before, and given what we are seeing globally, because we are now seeing some of the biggest earthquakes that the system can generate since 2004. We have been seeing these very large earthquakes. So we should not be taking the seismic threat casually at all. We should be ensuring that our preparedness measures are. So the faults are moving, and they are not moving smoothly past each other. So the Caribbean plate and the North American plate are converging, and the North American plate is sinking beneath the Caribbean plate in what we describe as a subduction zone. The earthquakes are generated when the faults stick and strain energy accumulates because of those frictional forces. And when the strain energy becomes more than the rocks can hold, it ruptures, the energy is released as waves, which you can record or feel as an earthquake. If you look at a plot of the locations of earthquakes that we have been recording since we started operations in 1953, you will see that north of St. Lucia, it's very busy. That is, we have several locations of earthquakes there, lots of earthquakes. And then south of Grenada, we have lots of earthquakes. But in the area between Grenada and St. Lucia, there are very few earthquakes. This is sometimes described as a seismic gap because it is a gap, as the word suggests, between these two areas. And the reason might be that the plates are locked, accumulating strain energy, and will one day rupture. If that is the case, because it has been accumulating strain energy for so long, then we would imagine that it has the potential to deliver a very significant magnitude event. Or the other possibility is that it just so happens that in this particular area, because it has been observed in other fault systems, where you have an area that the movement is relatively smooth, so you don't have that accumulation of strain energy, in which case there would be no large amount of energy being stored. So research is being conducted to try to understand just what is happening in that area. So this is the interesting thing about tsunami. The Indian Ocean tsunami is a particularly striking example. They don't have to happen often. You just need one, and given our vulnerability, the impact can be huge. And given how we have been developing in our region, we have had tsunamis in the past. We have had them generated on the Northern Caribbean, significant ones. We have had them generated in the Eastern Caribbean also. In general, not quite as dramatic and impressive. But yes, we may not have had this big dramatic earthquake with tsunami in the Eastern Caribbean as you would have seen maybe in the Northern Caribbean. But that doesn't mean that it can't happen. And the point is that given how we have developed, given the tourist industries in the various territories, the high density populations we have in coastal regions now, when such an event occurs, the impact is going to be huge. Have a tsunami that's generated by an earthquake that is further away, so like on the other side of the ocean, as happened in 1755, the Great Lisbon earthquake. So you would have a lot of time for warning because the tsunami has to cross the ocean before it gets to us. Or you can have an earthquake that occurs within our region. So a locally generated or regionally generated tsunami. So whereas it takes 7 hours to cross the Atlantic to get to us, when such an earthquake occurs right in our region, the closest island to that earthquake will be impacted within minutes. And the other islands would be impacted with longer and longer delays, maybe 30 minutes or so. And that sort of time is certainly for the closest island, there will be no time for an official warning. So you need as individuals, all of us need as individuals living in an island environment, people who like to go to the beach, we need to know the natural warning signs for the occurrence, possible occurrence of a tsunami. So if you feel an earthquake, that the shaking is so strong and you're by the beach, you can't stand, as soon as that shaking stops, you need to get to high ground. And that high ground does not have to be topographically high ground. It doesn't have to be a hill if one is not nearby. You can evacuate vertically, so you can get up to a higher story. Above the 3rd floor is recommended. And of course, in such things, the higher the better. And if you're very flat and so on, the further inland, the better, as far as you can get. So that's the shaking. Now, even before you feel the earthquake, it should be your responsibility for your own personal safety. I know that we as a people, we like to say the government hasn't done and the authorities haven't done. But we must learn to take a certain level of responsibility for our own safety. And if you are living in a coastal area that is vulnerable to tsunami inundation, then you should identify an area that would be safe for you, given where you live or work, and you need to walk that route. How do you get there? And you notice I say walk and not drive. Drive is not an option in this case. You have to get to that area as quickly as possible, and you may have to plot various routes to identify the most efficient and fastest way to get there. So this is a little project that each of us can undertake. So we know the route beforehand. When the earthquake occurs, you take your route and you get to safety. So as if you feel the earthquake. Maybe you don't feel the earthquake. Maybe it occurred further away than right close to your island, but still in the region. So you see the sea withdraw further than you have seen it withdraw. This is not like a low tide withdrawal. This is a fairly rapid withdrawal of the sea. And you're seeing all the shells and fish and so. And we must not allow ourselves to become fascinated by that, because there have been examples in islands of the Pacific where this has happened, and people have been killed because they become fascinated by the fish. They go collecting the fish, and then they are swallowed up in the wave as the water comes back. So the sea has withdrawn, you have felt an earthquake, so those are two signs that are natural warning signs. And the last sign is, because it isn't always that the sea withdraws. It withdraws depending on which part of the wave comes on first. So sometimes the wave just comes in a rush, But those who have experienced tsunamis say that sometimes you hear like a roar coming from the ocean side, and there's no plane overhead. That is possibly a tsunami coming, you head to high ground. So there are three possible warning signs. Any one, not all three, any one, if you feel the shaking, if you see the sea withdraw, or if you hear the roar, any one, you head to high ground.